The Physiology of Swallowing, an in-depth look. Hello, and welcome to today's episode, where we're diving into the fascinating physiology behind one of our most essential everyday actions, swallowing, also known as deglutition. It's a process that might seem simple, but it's actually an intricate neuromuscular event that safely moves food and liquids from your mouth all the way down to your stomach, all while ensuring your airway stays protected. So, let's break down this process step by step. Phase 1. The oral phase. Voluntary control. Let's start with the oral phase. Here, food is chewed and mixed with saliva to form a soft, cohesive bolus. Your tongue and cheek muscles work together, pressing the bolus against the hard palate. Once ready, the tongue propels the bolus backward, toward the oropharynx, using a smooth rolling motion, a process called tongue loading. At this point, the soft palate lifts slightly, preventing the bolus from spilling prematurely into the throat. Phase 2. The pharyngeal phase. The involuntary reflex takes over once the bolus arrives at the anterior facial arches. Those are the tonsillar pillars. The next phase is triggered, thanks to sensory signals sent via the glossopharyngeal and vagus nerves to the swallowing center in the brainstem's medulla. Here's what happens in quick succession. The soft palate rises, sealing off the nasopharynx to keep food from going up into the nose. The larynx moves upward and forward, tucking beneath the epiglottis. The epiglottis acts as a protective lid, covering the laryngeal inlet and guiding food toward the esophagus. The vocal folds and false vocal cords close tightly, shielding the airway. Pharyngeal constrictors contract in order, pushing the bolus downward. The upper esophageal sphincter, or UES, relaxes, allowing the bolus to pass into the esophagus. Phase 3. The esophageal phase. Peristalsis in action. Now, we move to the esophageal phase. Here, involuntary peristaltic waves, coordinated by the vagus nerve, propel the bolus downward. If any food remains, secondary peristalsis clears it away, triggered by local stretch reflexes. At the bottom, the lower esophageal sphincter relaxes, thanks to nitric oxide, and the bolus enters the stomach. The central command, neural control. This entire sequence is orchestrated by a central pattern generator in the medulla, specifically the nucleus tractus solitarius and nucleus ambiguus. Sensory input arrives via cranial nerves 5, 9, and 10, while the commands are sent out through cranial nerves 5, 7, 9, 10, 12, and upper cervical spinal nerves. Reflexes that protect our bodies are equipped with vital reflexes. The cough reflex expels any material that strays toward the airway. The gag reflex prevents unwanted entry into the pharynx. Why does this matter? Understanding swallowing is crucial, especially when things go wrong. Conditions like dysphagia, difficulty swallowing, can result from strokes, Parkinson's disease, or muscular disorders. If the airway isn't adequately protected, aspiration can occur, meaning food or liquid enters the lungs, which can be dangerous. And that's the science of swallowing, a remarkable, finely tuned process that makes eating and drinking safe and efficient, every single day. Thanks for joining us for this episode. Don't forget to tune in next time for more deep dives into the wonders of human physiology.